Good morning or good afternoon, everyone. Right, just checking that I'm still recording. Hold on. All right. Good morning or good afternoon, everyone, depending on what period you're in. So, I just recorded a lesson but forgot to click record. So we're going to try this again and hope it works. So if you keep seeing me check this sidebar, that's just so I make sure I'm still recording. Speaking of, let's just make sure. Yes. Okay, awesome. So I'm sorry I couldn't be there today, but I'm going to give you, to my best of my ability, like an improv lesson. So it's going to be remote, and you're going to just watch this video. And it shouldn't be too difficult because we're combining elements from yesterday's lesson on ASTC, All Students Take Calculus, which stands for all, sine, cosine, and all sine, tangent, and cosine. So that's where each function is positive. So we're going to combine yesterday's lesson with the lesson that we did before our test that involved the Pythagorean theorem and the Pythagorean identity, where we derived sine squared plus cosine squared equals 1. Remember where we just plug in for that value, square it, and find either cosine or sine, and then solve for tan? So we're going to get into that a little bit later in the lesson, but for right now, let's try the do now. So it says, which quadrant are you in if sine of theta is greater than 0 and cotan of theta is less than 0? So sine of theta is positive, cotan theta is negative. So cotan is 1 over tangent. That's the reciprocal of tangent, so that's going to be negative. So if we look at ASTC, we could see that sine's positive in all, obviously. All trig functions are. Sine's also positive in S. Sine and its reciprocal, positive there. Cotangent is positive where tangent's positive, but we're looking for where cotangent is negative. So that's also going to be where tan is negative. So tan's negative in cosine and sine. See how these two overlap right there in quadrant 2? That means that's our answer, quadrant 2. We want to see where both of these events occur. So quadrant 2. Awesome. Now for question 2, it says, suppose tan of theta equals 5 over 12, and an angle theta is an angle drawn in standard position that terminates in quadrant 3. Will cosine of theta be positive or negative? So, first, we're going to draw a little picture. So let's pretend we're in quadrant 3. Right? There's our ray. Let's say the point was right there. The tangent of that point is 5 over 12. Now let's just first think. If we have ASTC, ideally what should be the only positive trig function in quadrant 3? Tangent, right? And we could already see that it's positive, so that works out. Now, let's think about it. We could already say that cosine is going to be negative from this, but let's fact check it and see what cosine really would be. So this, you don't have to write, but it's just important for us to see. Remember, you get tan in South Carolina, sine over cosine. I know it's so annoying to hear me say, but you're going to remember it, so I have to. So they already give us the ratio of sine to cosine. It's 5 over 12, which is awesome because we could see that cosine is 12 and sine is 5. So could I say this point is 12, 5? No, right? Because 12, 5 would be up here. So I'm moving in the negative x and the negative y direction. So both of these have to be negative. So that would mean negative 5 over negative 12 equals 5 over 12. So that's where the positive tangent's coming in. So we're just focusing though on cosine. So they said, will cosine be positive or negative? Cosine's going to be negative. Cosine of theta equals negative. So you didn't have to show this whole work if you knew ASTC, but I think it's important for us to see just in the beginning where tan is defined and how we're getting tangent itself, and that I'm not just randomly assigning trig functions to positive quadrants. There's actual meaning behind it by the way the ray lands, where it terminates, and also where the xy coordinates are. So what I mean by that, it's like each xy, where that ray lands, and what function they're asking for. Because if they're asking for cosine or sine, it could affect the outcome of the sine itself. Like here, if they're asking for tangent, our answer would be positive. But they're asking for cosine, so it's going to be negative. Right. So let's try one. This was just all review. So this was from yesterday's lesson. I know a few of us found it a little difficult because it is a new topic. And obviously it's going to be hard the first time. And maybe today you might find difficulty with it too. Next week I could have extra help. We could go over it. No worries. But I think as we start to get through this lesson, you're going to kind of see the connections. So for number 1, let's just make sure. Good, we're still recording. It says, using the Pythagorean identity, so I'm just going to highlight this, find the value of cosine. So let's make cosine blue. And the value of sine is 0.62. We're in quadrant 2. So before we do anything, immediately to the side, draw a little xy axis. We put A, S, T, C, 1, 2, 3, and 4. They tell us we're in quadrant 2. So if we're in quadrant 2, sine's going to be the only positive function here. So I need to make note of that. Sine's positive. Cosine, when I find this value, it needs to be negative. Okay? So everyone make note of that. So the point here, the x direction is negative, but the y is positive. So therefore, cosine's negative. So if we do sine squared, this is just practice from sine squared plus cosine squared equals 1. I'm going to do 0.62 squared plus, you could leave it as cosine squared or make it x squared. I like to do x squared just because it's easier to write, but it's really up to you. Alright, I'm going to take out our calculators. We're going to do 0.62 squared equals 0.3844 plus x squared, which equals 1. Now basic algebra, solve for x, subtract from both sides. Right, so we get x squared equals 0.6156. And now we need to take the square root. When we take a square root has two answers. I know the calculator only spits out one, but there's a negative and a positive to that answer. So, say, let's take the square root of 4. We get 2, right? But what if I do the square root, let's do the second square root of negative 2 squared. I still get 2, and that's the same as 2 squared. So technically, this 2 as my answer could be a negative or a positive. In this case, see how we saw that in the beginning cosine was negative because of the placement of the quadrant? We're immediately going to know that x equals negative whatever spits out of the calculator. So I'm going to do second square root and get that 0.6156. X equals negative 0.785. So I'm rounding to the nearest thousandth. That's 3 decimal places. And I look to the decimal place next to it, which is a 6, which means round up. So that gets us negative 0.785. So I had my cosine of theta. Negative 0.785. Now, I'm looking to find the tan of theta. So if you recall, the tan of theta is, where do you get tan? South Carolina, right? So the tan of theta is going to be sine theta over cosine of theta. So cosine's here, cosine, and we have sine on the top. So if I fill in my question, sine is 0.62. So I directly just grab that from the question. Now cosine's the part that I solved for, so I could just plug in my answer, negative 0.785. Okay. Now simple, all I'm going to do is divide. So I'm going to go alpha y equals, enter, to get that fraction bar and get 0.62 divided by negative 0.785. And I get negative, they said the nearest hundredth. So we're going to go negative 0.79 because it's 2 decimal places and the decimal next to it is a 9, so we're going to round up. So negative 0.79. So the tangent of theta and now you could check yourself. If you got a negative answer for a tangent, is that right? If we look, yeah, that is right, because only sine's positive there. So there's no reason why a tangent should be positive too. Both cosine and tangent must be negative in quadrant 2. So that could be like a little check to yourself, like, okay, I'm headed in the right direction. At least I got that part right. Maybe I made a computational error, but that could be a little help for you. All right. Now I'm going to help you guys on question 2.2. 2.2. That's repetitive. All right. Let's just see. Let's make sure we're still recording. Awesome. So number 2 says, using the Pythagorean identity, and I'm not even kidding to you. My video before was so good. Of course, it got deleted classic, but we'll make this one great too. Okay, so sine squared theta plus cosine squared of theta equals 1. So this is just being copied directly from here. They want us to find the value of sine now, and they give us the value of cosine, and we're working in quadrant 3. So first, let's draw out where quadrant 3 is. A, S, T, C. 1, 2, 3, and 4. Alright, so quadrant 3 is right here. And let's say our point's right there. So they tell us that cosine's negative here. So we have a negative x. Or as we could say, they give us the x value, negative 0.47. Right? What would the y value be if we look? Would it be positive or negative? We're going down to get that y value. So it's going to be negative. So it's going to be a negative y. So sine must be negative. Right. Pretty interesting, right? So now when we plug in for sine, cosine, we have to be aware of that when we're solving. So sine is going to be x squared. You could leave it as sine squared. That's perfectly fine too. Equals 1. I'm going to plug negative 0.47 squared into my calculator. I like to use parentheses to avoid any confusion because we know we're smarter than our calculators. X squared plus 0.2209 equals 1. Now basic algebra, just subtract. And we get x squared equals 1 minus, we get 0.7791. Now here's the thing, when we take the square root, remember there's could be two possibilities. And like we said earlier, sine must be negative quadrant 3. So second square root 0.7791, we get x equals 0.88 rounded to the nearest hundredth, like it says here. So make sure you put your negative in. I said it, but I didn't write it. Make sure you write it. The sine of theta equals negative 0.88. Right. Now, we're going to do the tangent of theta. Ooh. You get tan in South Carolina, sine over cosine. And now we just plug in. So cosine, they give us in the problem, negative 0.4, negative 0.47. My bad, that goes on the bottom. Sorry guys. Negative 0.47, and sine we found. It's negative 0.88. So now if we plug that in, alpha y equals negative 0.88 divided by negative 0.47. I get 1.87 because they said nearest hundredth, and there's a 2 next to my 7. So nearest hundredth is 2 places, right? And we look to the right and we see there's a 2. So we're going to keep the number we're at. Equals 1.87. So the tangent of theta equals 1.87. So that kind of makes sense though, because we just divided a negative by a negative. So automatically you should be like, okay, this should be positive. But relating it back to quadrant 3, we know tan's the only positive one here. So obviously, this answer should come out to be positive. So again, this is just like a little reminder. I mean, it's an annoying step to have to do, but it is crucial, and it's a big part of algebra to identify what quadrant you're working with, and ASTC does come up a lot. So it's important that we learn it, and you guys, I know, can do this. So I'm going to leave you to do 3 and 4, and 5 also, because 5 and 6 are similar. They both have a fraction, but 6 I'm going to do with you because, in my opinion, negative 12 over 13 is a lot more scary than 5/7. I know, it might be crazy, but that's my opinion, to each their own. Alright, so don't get nervous. We're going to do the same exact thing. So we're working with sine squared plus cosine squared equals 1. Let me do a check. We're still recording. Alright, we want to find cosine. Cosine we did in blue, and they give us sine. We're working in quadrant 3. Alright, before we do anything, let's see quadrant 3. This was like the problem we just did. We're in quadrant 3. It falls where tangent's positive, like we just saw. So this is 1, 2, 3, 4. So tangent is only positive in quadrant 3. So we'll keep that in mind here. Tangent positive. And our cosine value then must be negative, because tangent's the only one positive there. So we're going to go through the same process. Sine squared of theta, cosine squared of theta equals 1. And then we're going to plug in. Negative 12 over 13 squared plus x squared equals 1. And I'll highlight for you guys so you can see exactly where these are coming from. You could also leave cosine as just cosine squared, but I like to fill it in for x because it's just easier than writing out cosine. Alright, now a lot of you are probably like, how do I type this into my calculator? You're going to go put a parenthesis just so the calculator doesn't get confused, because sometimes it does. Make sure you put your negative in, because we're squaring things. We need to keep the parentheses, you know. And then put your negative. And then we're going to go alpha y equals enter to get the fraction bar. Type in 12 over 13. Oh, not 3. 13. And then square that. Now, on your paper, you could just do about, let's say, 5 decimals and put a little dot, 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 plus x squared equals 1. Then we're going to subtract, but do not erase this value from your calculator, because we need to use that exact value, so we're not off with our rounding. You know, you never want to round too early. So we're going to go 1 minus, take that value, we get 0.14792. 3. 0.14793. Awesome. Now, like I said, when we take the square root, we get 2 values. So let me take the square root and let me show you what I'm talking about. I'm taking the square root, taking the square root. And make sure you take the square root of this whole value and not just the rounded version. Remember, there's a dot, dot, dot. continues to go on. So we get this value 0.3846, so on and so forth. But that value could be both positive and negative, because when we square a negative, it becomes positive. So x, in this case, x or cosine, is going to be negative. So it's going to be negative 0.385. Again, just another step from what we were doing before. So the cosine of theta. Make sure you always, though, if you substitute it in for x, rewrite it as cosine or sine or tan, whatever you're solving for. 0.385. Awesome. Now, we got cosine, right? They ask us for tangent. So, same process. You get tan in South Carolina. You know it's annoying. So we're just going to rewrite. They give us sine here, negative 12 over 13. Plug that in. Divided by, we found cosine, negative 0.385. I'm going to plug this into your calculator. It looks a lot scarier than it is, but it'll go perfectly into the calculator. So everyone take out their calculators, and you're going to go alpha, y equals, enter. And then we need another fraction bar. So we're going to go alpha, y equals, enter. We're going to go negative 12 over 13. So perfect. We have our top fraction. Now on the bottom we have a decimal. We know how to plug in a decimal. 0.385. And then we get our answer of 2 to the nearest thousandth, so 3 decimal places. So 3 decimal places would be a 7, and right next to it's a 6, so that means we round up to 8. So this equals 2.398. So the tan of theta, notice how I rewrite it, equals 2.398. Go over in green. And if I look back, I had my mental note here that tangent was positive. And if we look, we're working in quadrant 3. Quadrant 3, tangent is going to be positive, which is really cool. So, I love when it works out like that. It's so satisfying to me. I don't know if it's just because I like math, but I feel like there's always a solution. That sounds corny, but honestly, I feel like this is so satisfying because we could prove where sine, cosine, and tangent all come from and why their values are positive or negative based on the quadrant they lay in. So, I want you guys to work for the rest of the period. You could work with a partner on 3, 4, and 5, and you're going to hand this in to the sub and thank her or him for being so nice and watching over you guys. And please be on your best behavior. And thank you guys for dealing with me being out right now. I promise I'll be back on Monday. Email me with any questions. And yeah, I hope you have an amazing weekend. Thank you guys. And enjoy my second video. And hopefully I actually recorded this.